Hi everyone. Today we're going to be looking at how to graph the transformed version of an absolute value function. So in your notebook, please put down today's subtitle, Transformed Absolute Value Function. The rule of a transformed absolute value function has the following format. Y equals A multiplied by the absolute value of x minus h and then plus k. Sometimes there could be a b value inside the absolute value expression, but we'll learn how to deal with the presence of the b value in another lesson. Let's focus on the most relevant, being a, h, and k. First, let's deal with how the variable a affects the overall shape of the absolute value function. The value of a causes some stretching and flipping to happen. If the value of a is positive, then we're going to get a normal looking V shape, and if the value of a was negative, we're going to get an upside down V shape. Does this look familiar? It should if you've already done quadratic functions. And if you have in fact already studied quadratic equations, then you may also be able to predict how h and k affect the overall look of the graph. You'd be correct if you guessed that h reveals the x-coordinate of the vertex and k reveals the y-coordinate of the vertex. Let's get this information about the vertex down immediately. So the vertex is revealed by the coordinate h and k. Now, the value of h also reveals something important. Notice that in this type of graph, the left side of the V-shape and the right side of the V-shape are symmetric. So the h value also reveals the axis of symmetry. The axis of symmetry is identified by x equals h. The next clue that we'd like to have to draw a decent graph are the zeros, if any. And to calculate the zeros, the calculations are identical to how they are done in any other function. Specifically, all we have to do is set the value of y equal to 0 and solve for x. Except in this case, we're solving absolute value equations. And the last piece of information that we'd like to have to help us draw a decent graph is, of course, the initial value. And to calculate the initial value, it's done the same way as any other graph. We set x equal to 0 and solve for y. With all these clues, we'll have more than enough information to draw a pretty decent graph. So let's try one. Put example, please. Suppose I ask you to draw the following absolute value function. Y equals -4, absolute value of x minus 3, and plus 4. Now, I'd like to first identify our variables a, h, and k one by one. But before we do that, I'd like to highlight one particular danger about the value of h. If you've already studied the quadratic function, you may already be aware of this danger. The -3 that you see here, the danger is that many students will believe that the value of h is -3. But in fact, it's actually +3. And here's why. Remember that the expression is normally written as x subtract h. So the only way for a -3 to actually show up is if it was x subtract +3. So therefore, the value of h is actually the opposite of what you see written on paper. If you see -3, then the value of h is +3. Okay, let's get back to identifying our variables one by one. So the value of a is -4. The value of h is in fact +3. And the value of k is 4. Now, with these three variables clearly identified, let's get all our clues together. The first clue is that a is negative. That means that this graph is going to be an upside down V shape. Next, let's identify our vertex. The vertex is identified by the coordinates h and k. So, that means our vertex will be located at 3 and 4. Next clue, let's calculate our initial value. So the initial value is calculated by setting the value of x to 0. So y is equal to negative 4, absolute value of 0, subtract 3, and then plus 4. So let's calculate that. This will give you negative 4 multiplied by the absolute value of negative 3 plus 4. And that will become negative 4 multiplied by the absolute value of negative 3 is positive 3, and then plus 4. And our final answer to the initial value is that y is equal to negative 8. And for the final clue, let's calculate our zeros, if there are any. So zeros. Alright, for the zeros, we're going to set the value of y to 0 and solve for x. So we have minus 4 multiplied by x subtract 3 plus 4, and setting y equal to 0. Okay, let's isolate our absolute value expression. So this will give us minus 4 multiplied by x minus 3, and the plus 4 goes to the other side, giving us negative 4 on the right hand side. Let's continue isolating our absolute value expression. So we have x minus 3, absolute value, equals to negative 4 divided by negative 4, which gives us positive 1. So, therefore, the x minus 3 could either equal to minus 1 or positive 1. So therefore, x minus 3 could equal to negative 1, or x minus 3 could equal to positive 1, and that gives us x could equal to 2, or x could equal to 4. So our zeros are located at x equals 2 and x equals 4. And guess what? With all these clues, we are ready to draw this graph. To accommodate all the information that we just found, please pause the video and prepare a grid that's about this size. Go ahead, draw it now. Okay, let's get all our clues down one by one. As usual, I'm going to be drawing my graph in a different color. First things first, let's get the vertex down. Our vertex was located at 3 and 4. So I'm going to put 3 and 4. There's our vertex. I'm going to label it with a letter V. Next, we had calculated the initial value. And the initial value was located at y equals negative 8. So I'll put the initial value right there. Y equals negative 8. Alright, and finally, we calculated our zeros, and they were located at x equals 2 and x equals 4. And with those 4 points, believe it or not, we can draw a pretty decent looking V-shaped graph. And there it is. That is my completed absolute value function. And that's all there is, ladies and gentlemen, to how to draw the graph of a transformed absolute value function.